Okay, so in this video, I'm going to take you through every question that is about functions in the algebra topic. And like I say at the beginning of every single one of these videos, this document is available for you. It is linked in the description and it's fully hyperlinked PDF that will allow you to kind of see every exam question that's been asked up until 2021. So we're going to look at some function notation here. These are actually really interesting questions because I think they often start off with some really easy parts where everyone could get the marks, and then they have some things later on that do get a lot more challenging. So always worth doing at least some of these questions, even if you're not sure what kind of grade you're aiming for, even if you don't want to go for like the top grade, there's going to be some easy bits here. So all this means is, because f of x is the function, it's just saying whatever x is here, you substitute it in. So if it's a -5 that we have here, we're literally just going to substitute it into that function that we've got. So f of -5 is 2 over -5 squared. And we're just really making sure we put the -5 in brackets. I'll show you what I mean by that, because if we don't put the -5 in brackets, we will get a different answer. So I'm going to do the 2 over -5 squared. So the answer is 0.08. Of course, you could give that as a fraction. Look what happens though, if I don't put the brackets around it, the calculator thinks that you're going to get a negative answer. It thinks it'll be negative 0.08 because it's actually squaring the 5 and then making it negative. But what we want to do is we actually want to square it we want to make it negative and then square it. So it should be 0.08. Now this one is an example of a composite function. What you do for f of g of 1, the first thing you do is work out g of 1, and then you put g of 1 inside f. So g of 1 means you put 1 inside here, which is going to be 4 multiplied by 1 cubed. 4 multiplied by 1 cubed, well that's just 4 times 1, which is 4. So f of g of 1 is actually saying put 4 inside f, which means it's 2 divided by 4 squared. I'm going to be lazy and put it on the calculator because that's what it's for. It's a calculator paper, and 2 divided by 4 squared is 0.125, or of course you could write that as a fraction as 1 over 8. So let's double check we've got these. So we've got 0.08 and 1 over 8, the equivalent of that is also 0.125. So it doesn't really matter which way you want to go for this. Again, some easy parts here that I think everybody should get right. It says f of x is 4 sine x, find f of 23, giving your answer to 3 significant figures. So f of 23 means just put 23 where x is. So that's 4 sine of 23 degrees. Now you don't have to type in the degree sign when you put it in the calculator. I'm just going to type in 4 sine 23. You don't need to put the degrees in, and we get the answer 1.56, and that is to 3 significant figures like the question asked for. It then says for this part, g of x is equal to this, find f of g of 34. So I'm going to do like I did in the previous part. I'm going to find out what g of 34 is, and then I'm going to put that into f. So you always start off doing this, the part that's next to the number. So g of 34, that's going to be 2 times 34 minus 3. Well, you could do this on the calculator. That's 68 to take away 3, which is 65. So this means that f of g of 34 is actually saying just put 65 inside f. So that's going to be 4 the sine of 65 degrees. I'm going to type that on the calculator and give it to 3 significant figures. I'm going to put it underneath here though, so I've got enough space. So I'm going to do 4 sine 65, 4 sine 65, if I can type better, and that's 3.63. So that is 3.63 to 3 significant figures. Okay, we've now got h of x is equal to x plus 4 squared, and Ivan needs to solve the following equation, that h of x equals 25. He writes this thing, and it says this is not fully correct. Explain why. Well, he's written h of x, which is here, and he said that it's equal to 25. He's taken the square root of both sides, and he's subtracted the 4. It says it's not fully correct, which means that it's partially correct. So I think the mistake is from here to here. He only took the positive square root, and he should have also found the negative square root. So explain why he did not use, or he did not take the negative square root of 25. He did not take the negative square root of 25. So we've got 1.56, 3.63, and that last part. So yeah, positive and negative square root is required. Could have found out the other parts, but these are the right kinds of things that we could have said in my one there as well. Okay, so here we have got some slightly harder questions. This is question 22, so it's right near the end of the paper, and it's also a 5 marker. We've been told what f of x and what g of x is, but we haven't been told what these values a and b are, and that's what we're going to try and find. Now there's kind of like two parts of this question. There's going to be this part, which I shall do in blue, and then this part, which I'm going to do in black. In fact, I might do some of this in black, and I might do some of this in red. So I'm going to start off with the blue part. It says that g of 3 equals 20. So if I put 3 inside the g function, if I find out what g of 3 is, g of 3 is when you put 3 in here. So that is going to be a multiplied by 3, which is 3a, plus b, and that is equal to 20. This is g of 3, and it's equal to 20. Now I'm going to do the next easiest part, which is I'm going to find out what g of 1 is equal to. Now g of 1 is when you just put 1 inside this. So g of 1 is just a plus b. Now I'm going to try and find out what is the f inverse of 33. That little one means it's f inverse. Now if you're ever trying to find this where you're putting an input into an inverse function, well, that doesn't mean put 33 into this. It actually means something different. It means make the function equal to 33. Now the reason this is true is because if you have a function f of x, when you put x into it you get f of x, and when you do the inverse you go back to the original one that you've got here. So if we're saying that you're wanting to put like 33 into the inverse function to go back to the beginning part, well, that's actually the same thing as saying that it is equal to the original function that we have. If that bit confused you a bit, I am going to do some more videos on function notation soon, but if you ever see this kind of thing, just make the function, instead of inputting 33 here, make it equal to 33. That's the quickest way of doing these. So when I solve this, I get that 5x is equal to 30, which means that x is equal to 6. And we were told that these two things are equal to each other, which means that the 6 must be equal to the a plus b. So from the first part, the 6 must be equal to the a plus b. So 6 equals a plus b. All I'm going to do now is I'm going to take this one, and I'm going to solve them simultaneously up here. So I have 3a plus b equals 20. And I have a plus b equals 6. Now it's a calculator one, but I'm going to just do, obviously, solving simultaneous equations. I don't think I'm going to need to use the calculator. If I subtract these, 3a take away a is 2a, and the b's cancel, and 20 take away 6 is 14. I'll then divide by 2 so that a is equal to 7. And if you just kind of look at using this equation, if a is equal to 7, we get 7 plus b equals 6. So I do 6 take away 7, and I get that b is minus 1. So a is 7, and b is minus 1. There it is. Okay, so you could have found the inverse if you wanted to, or you could just do this thing that we were suggesting here, that f inverse of 33 is equals 6, okay? So here we've got two different functions. We've got f of x and g of x, and we're going to show that g of f of x is this thing. So this means take f of x and put that inside the g function. It kind of goes backwards to how you'd expect. So we're going to take this and we're going to substitute it where that x is there. So g of f of x means it's going to be 2. Now instead of writing x in this second one that I've got here, I'm going to write this. So I'm going to write x plus 1 squared minus 1. Now I'm hoping you can see this f function is here, and it's inside the outer function, which is the g function that we have. So all we need to do now is some expanding brackets and see what happens. So inside these brackets, x plus 1 squared is x squared plus x, which is plus 2x, plus 1 minus 1. So it is 2 brackets x squared plus 2x. Now I can factorize here. I can take a factor out of that bit. I can take a factor of x out, which just leaves me with the x plus 2 as is in the question. And then this one is like on the previous page. Do you remember I said that if it says put 7 inside the inverse function, well, we know that if you make this thing equal to 7 and you find out what x is, it tells you what was originally put in. I wonder if I can explain that better. That if we're saying that there is some function, some number x, you put it inside the g function that you get, and you get the answer 7. If you put 7 inside the g inverse function, you should get x. So we can actually just make the original function equal to 7. Now, if you find that a bit confusing, that's not a problem, but this is something that if you just learn, let's say it's kind of last minute, if it looks like that, instead of substituting 7 in, make it equal to 7. So 2 brackets x minus 1 is equal to 7. I'm going to divide both sides by 2, so x minus 1 is equal to 3.5, and then I'm going to add 1 on, so x is equal to 4.5. Let's just write that 5 a little bit neater. So we get x is 4.5. And the first one was a show that question, so it's pretty done for us. And if you wanted to, you could have found the inverse function of g, and then you could have substituted 7 into that. But look, there's this other thing that you could do of just saying that it's equal to 7 instead. Okay, so we've got these two functions here, and we're going to find the inverse of f of x. So this one, we are going to think, I'm going to show you kind of like the shortcut method, and then sort of like the foolproof method afterwards. So if you think about what's happening to x here, it is multiplying by 3 and then subtracting 1. So if I wanted to do the opposite of that, that was that it was multiplying by 3 and then subtracting 1. If I want to go backwards, I have to do the opposite. So the last thing that happened was that it was subtracting 1. So the first thing I'm going to do to x is add 1, and then instead of multiplying by 3, I could divide by 3. Now the alternative method for this is this one, and it always works, and it would work if you go all the way to A level. You will write out what the equation is as y, so you'd say that y equals 3x minus 1. You would swap the x and y values, and then you make y the subject. So x equals 3y minus 1. I'm then going to add the 1 and divide by the 3, and that tells me what y is equal to, which therefore tells me that the inverse function of x is what we have on the other side, which is x plus 1 over 3. Okay, here it says that f of g of x is equal to 2 lots of g f of x. Show that this thing is true, and this is 5 marks. So I'm going to do this thing in blue, and then I will do this thing in black, and then I will hopefully come up with this thing in red at the end. So f of g of x means take g of x and put it inside f. So f of g of x means I'm going to take g of x and put it inside f. F is 3 brackets, 3x minus 1. So instead of putting x, I'm going to put x squared plus 4. So that's my 3x part of f of x, and then it's minus 1. So that is 3 brackets, or no brackets actually, 3x squared plus 12 minus 1, or 3x squared plus 11. Now I'm going to do my 2g f of x. 2g f of x. I'll tell you what, let's leave the 2 off for now, and we'll just do the g of f of x, which means you're going to put f of x inside g. So instead of it being x squared plus 4, it's going to be 3x minus 1 squared plus 4. So 3x minus 1 squared, if you need to do the double brackets on that, so you have your 3x minus 1, 3x minus 1, then go for it. But I know that that is going to be 9x squared. There'll be a minus 3x and a minus 3x, which is minus 6x. There'll be a plus 1, and there'll be a plus 4. So it is 9x squared minus 6x plus 5. Now 2g f of x means you're just doubling that because it's got a 2 at the front. So it's 18x squared minus 12x plus 10. Make sure that everything gets doubled. And then the last part I'm going to do is I'm going to make this thing, which is f of g of x here, I'm going to make that equal to 2 of g of f of x, and I'm just going to make them equal to each other. So we get 3x squared plus 11 equals 18x squared. Hopefully I can fit this all in. Let's just quickly give myself a little bit more space. Equals 18x squared minus 12x plus 10. And they've made it a quadratic where it's all equal to 0, so I'm going to have this part as a 0 and subtract from the other side. So 18x squared take away 3x squared, that's 15x squared. We've then got the minus 12x, and when I do the 10 take away 11, I get minus 1, and I come up with the thing that they wanted right here. I'm just going to erase this because I don't think we need that part there. And there was the inverse function, and it has been shown it was what we were doing in that part there. 5 marks, quite a lot there, okay? So here we've got a function. It says f of x is 2x cubed minus 4. Show that the f inverse of 50 is equal to 3. Well, we've done this loads before. This thing on the left-hand side just means solve this equation being equal to 50, okay? Normally, if it was f of 50, you just put 50 where x is. If it's f inverse, you solve it being equal to 50. So we're going to get that 2x cubed minus 4 is equal to 50. So 2x cubed is 54. I'm not going to cube root. The first thing I'm going to do is divide by 2 because of BIDMAS, and half of 54 is 27. And when I do the cube root of 27, I get that x is equal to 3, which is exactly what they wanted right here. So we get that the answer 3. So I can say hence f inverse of 50 is equal to 3. Okay, the functions g and h are given by this thing here. Find the values of x for which h of g of x is equal to 3x squared plus x minus 1. So I'm going to go straight in and I'm going to put g of x inside h. So that means I'm going to put that inside that function. So instead of it being x squared, it's going to be x plus 2 squared, and they want that to be equal to 3x squared plus x minus 1. So that is x squared. The left-hand side is going to have a 2x and a 2x, which is a 4x plus 4, equals 3x squared plus x minus 1. Now it's a quadratic, so I'm going to get it to equal to 0. I'm going to subtract the x squared from 3x squared, which gives me 2x squared. I will do x, take away 4x, which is minus 3x, and I will do minus 1 minus 4, which is minus 5. Now, however you want to factorise this, I think this one we can probably do by a bit of guesswork, really, because I know that the first numbers are going to have to be a 2x and an x, and the only things that multiply to 5 are going to be minus 5 and 1. So I think if I probably put like a minus 5 in here and a 1 in here, I would get minus 5x plus 2x, which is minus 3x. And so we can now just solve this. Now, if you needed to do the full process, you know, when you do like the AC kind of method, of course you could do that, but I'm just saving me a little bit of time. And I think when it's a nice, easy number here and here, you can kind of do the guesswork approach for this. So from this bracket, we can see that x would be equal to 5 over 2. And from this bracket, we can see that x would be equal to minus 1. So the possible values of x that we've got here are 2.5 or 5 over 2 and minus 1. So there's our minus 1 and our 2.5 or 5 over 2. Of course, that's acceptable as well. And we have got this part here for solving this part and then solving it to give x equals 3. Okay, nearly here with the functions questions. F and g are these two functions, and it says find g of 5. So everybody could do this. This literally just means substitute 5 into this part. So 2 times 5 is 10. I'll tell you what, I'll just write it out slightly more slowly. 2 times 5 plus the 1. So that's 3 brackets. 2 times 5 plus the 1, that is 11, and 3 times 11 is 33. I also think everyone could do this one. So we're going to first of all work out what f of 9 is. So that is 12 divided by the square root of 9. And 12 divided by the square root of 9 is 12 divided by 3, which is 4. So g of f of 9 is actually just saying put 4 inside g. Now when you put 4 inside g, that is going to be 3 brackets, 2 times 4 plus 1, which is 3 brackets 8 plus 1, 3 times 9, which is 27. Now, quick side note, people go, oh, but I'm taking the square root of 9. Shouldn't I have plus or minus 3? It doesn't say plus or minus in the front. It's already got the square root. If we are taking the square root, then yes, of course, it would be plus or minus. But the square root has already been taken, and it's the positive one, which is why there's only the positive version of this. Last one, they seem to love these kinds of questions. You don't want to put 6 into the function. Instead, what you want to do is make this function equal to 6. And I've done a little bit of an explanation of that, but I find it quite a tricky one to explain. So we're going to make this thing equal to 6. You could expand the brackets if you wanted to. I'm actually going to divide both sides by 3. If I divide both sides by 3, I get this. And then I'm going to subtract the 1. Give myself a little bit more space is what I'm also going to do. And then I'm going to divide by 2 so that x is equal to a half for that last bit. Okay, let's double check we've got these right. We've got 33 and 27 and then a half. Yep, 33, 27 and a half. Of course, there are other ways of doing this one, so if your teacher has shown you it in a different way and you feel more comfortable with that, absolutely stick with it. But you've seen I've done quite a few of them here and they seem to ask this question a lot. Okay, so we've got these two functions and we want to find out g of f of 1. I'm going to go a little bit faster. I'll find out what f of 1 is. So it's 3 times 1 squared plus 1. So that's 4. So g of f of 1 literally just means let's put 4 inside the g function, which is 4 divided by 4 squared, or 4 over 16, which is just a quarter, or 0.25. And then it says the function h is such that h is the inverse of f of g. So what we're going to do for this is we're going to begin by finding f of g of x, which means you're going to take g of x and put it inside f, and then we're going to find its inverse afterwards. So g of x is 4 over x squared, and we're going to put that in here. This is a horrible question, by the way. So it's 3 lots of, and instead of writing x squared, I'm going to write 4 over x squared squared. So I've taken this g and I've replaced it inside that x. It's like substitution within substitution. And then I have plus 1. So this is 3 multiplied. 4 over x squared squared is 16. Don't need the multiply sign, I'll do it with a bracket. Is 16 over x to the power of 4 plus 1. And when I multiply these two things together, it's just the 3 times it by the numerator. I'm going to get 48, because 3 times 16 is 48, over x to the power of 4 plus 1. Now what I'm going to do is I'm going to try and find out the inverse of f of g of x. The way I'm going to do this is I'm going to say that y equals 48 over x to the power of 4 plus 1, and I'm going to do my x and y swap, and then I'm going to make y the subject, okay? So when I do my x and y swap, I get that x equals 48 over y to the power of 4 plus 1. So I'm going to subtract 1 from both sides, so x minus 1 equals 48 over y to the power of 4. Now I can take reciprocals of both sides, which is basically these two things swapping places. So if I then come up here one final time, I'm going to get that y to the power of 4 is equal to 48 over x minus 1. So I could have taken the reciprocal, or I can see that these two things are just switching places. The y to the 4 comes up, and the x minus 1 goes down. And then my last thing is to do the 4th root of that, which is kind of unusual. You wouldn't really expect to see something quite like this in GCSE. So we're going to say then, just to finish off the question, that h of x is the 4th root of 48 over x minus 1. So if you did this in November 2021, what a horrible question that is there. So let's double check. We've got a quarter and the 4th root of 48 over x minus 1. Now that's all of the stuff that has been asked on functions. I think you'll agree there's quite a lot of these questions that are being asked, and pretty much part A is always going to be easy. This one, I think, if you can learn that instead of substituting 6 in, you just make it equal to 6 if it's with an inverse function, I think you're going to be getting even more marks and boosting your grade up as high as it can possibly go. If you found this useful, please do like it, share it with someone, subscribe to the channel. It really does just help this reaching lots of other people. And if you do move on to start doing A-level, I have a quite popular A-level channel that has got tons and tons of lessons as well. So good luck with all of your studies.